afternoon. Welcome to NPTEL project on econometric modeling. This is Rudra Pradhan here. Today we discuss the concept probability. In the last lectures we have discussed various aspects of econometric modeling, that is the structure of univariate modeling and bivariate modeling. In the univariate modeling we have discussed central tendency, particularly mean, median, mode, dispersion, that is range, quartile deviation, mean deviation, standard deviation, coefficient variation, and skewness, that is the shape of the distribution. On the other sides we have discussed correlation and regression, that is to know the association between the two variables and the causality between the two variables. Now the issue is whether you go for univariate modeling or bivariate modeling. We must like to know whether the univariate modeling or bivariate modeling has its uniformity or has its feasibility. So far as a feasibility is concerned, or strengthness of this modeling is concerned, or validity of the model is concerned, or significance of the model is concerned, we have to know or we have to add certain things here. The issue is that we like to justify whether the particular setup, that is univariate setup or bivariate setup, are relevant or significant one. To justify the same, we like to know the concept of probability estimation and hypothesis testings. So probability estimation, hypothesis testing plays a fantastic role so far as a significance of a particular variable in a modeling setup. So whether you apply univariate statistics or bivariate statistics or multivariate statistics, you must have complete information and or complete structure of the models, and that model has to be statistically significant. So now in this particular lectures we like to know how probability can be applied or can be used to know the significance of a particular variable or significance of the model, that means the overall fitness of the models. So now what is all about this probability? Probability is basically, you can say, chance of occurrence. So it is a quantitative measurement of uncertainty. In the real world situations, you will find some of the things are very certain and some of these things are very uncertain. So that is how in the beginning we have mentioned the difference between the social science structure and, you can say, mathematical science structures. In one side the relationships are exact in nature, in other side the relationships are inexact in nature. The moment you will say relationships are exact, then obviously this is one way we can say that the situations are very certain, very clear. So no point to go for verification, or you can say any statistical tool to estimate or to check reliability, etc. But in reality there are so many things are there, we are not sure about the effect. So that means there is always question of uncertainty. So now when there is a question of uncertainty, we try to justify how it can be possible to measure, or you can say how you can justify the situation. So when it is uncertain, so what is the percentage? So that means how much different from the certainty. So now in that case probability plays a fantastic role. So the basic meaning of probability is the quantitative measurement of uncertainty. So it measures the degree or chance of occurrence of an you can say uncertain event. So I will take a case here. let us take a case of I will toss a coin. Let us say coin is a examples. So, now if I will toss a coin, then obviously its outcome is either head or tail. So, now how probability can play a role here. So, now the moment you will toss a coin, then obviously we have two possible outcomes, either you will get head or you will get tail. So, now the question is whether you will get head or whether you will get tail. So, now this is not at all certain. So, now uncertainty has to be applied. So, now take another case. So, now there are two persons, say x and y. Okay. So, they like to toss a coin. So, now in the x case the possible outcomes are head and tail, and in the y case the possible outcomes are also head and tail. So, now if both the person at the same time toss the coin, then obviously what is the chance of occurrence, or what is the chance of belief or chance of occurrence. So, now the moment both the person, you can say, try to toss the coins, then obviously there is several possibilities. First, both heads can occur, both the cases both head can come, then second case both tail can come, and third case one tail and one head. Okay. So, there are three possible situations are there. So, we have to make an experiment, what is the possible outcomes and at what extent we have to bear it. So, in that context, probability plays a fantastic role. Let me explain what is all about this probability structures. Probability basically divided into two parts. Probability we can measure in two different angles. One is called as a objective classification, then another is called as a subjective classification. Okay. In the case of objective classification, it basically depends upon equal likely events. Equally likely events. Okay. In the second case, subjective classification, we usually look for personal judgment. For instance, take a case of election, snowfalls, etc. So, in the case of objective classification, equal likely events, the same thing, toss a coin, pick a card, or toss a die, etc. So, in that context, so subjective classification of probability plays a fantastic role. So, probability basically can be measured in objective angle and can be measured in subjective angles. So, in one case equal likely events must occur, in another case it is based on the personal judgments. Equal likely events means the cost of a particular outcome may not depend on the cost of other item. So, this is how the objective classification and subjective classification. So, now the issue is here. So, what is the exact structure of probability and how it is, we can say, applied in the econometric modeling. Basically, probability can be applied purely on mathematics and purely on statistics, but in this econometric modeling, particularly when we go for multivariate framework, when the problem involves so many variables at a time, then we like to know which particular variable is much impact, and if it is, or if it has impact, then how much, and whether the impact is statistically significant. So, in order to know all these answers, then probability has to play the game. So, now probability will give you indication whether it is significant, or if it is significant, what is the level of significance. So, that is how we have to justify. In that context, probability plays a fantastic role. So, we like to know the detail about the structure of probability before you apply it in econometric modeling. So, now, so the concept of probability is a very very big, it is a broader angles you have to describe, but in the meantime we have to just discuss the concept very briefly. So, our point is here to know what is exactly probability, how is it set up, and how it can be used in the econometric angles. Okay. So, now to know the detailed concept of probability, so we must know something about the concepts of probability. So, to interpret the term probability, you must have a thorough knowledge of its components. So, one of the basic components, that is what we will say basic components of probability. Okay. First is a set. So, now in mathematics there is a concept called as a set. Set means well defined objects. The object may be in different way, may be different shape, different structure, etc. Here the starting point of this probability is, you can say, the set theory. So, this set theory plays a fantastic role in probability. So, we have various concept of set in the probability theory. So, now set we are describing two ways. One is called as empty set and another is called as universal set. Empty set means if the set has no element, okay, no element, and universal set means all possible sets of all possible sets of outcomes, possible sets of outcome. Okay. So, now let us take a case here. This is the set, we will call it a universal set S. Okay. So, now S, inside S we have a set called A, all right. So, now this is a particular set A, and or you can say event A, then S is the complete set. So, this is otherwise called as a universal set. Universal set means it is the integration of all sets at a time. So, within the universal set we have a subset. For instance, just like we have discussed the multivariate bivariate framework, within the bivariate framework we have bivariate analysis, and under bivariate analysis or again multivariate analysis we have again univariate analysis. So, now the structure is almost all same here. So, we are discussing about the universal set. So, within the universal set we can describe or we can pinpoint a particular set also. So, now what is all about set, what is empty set, what is the universal set. So, empty set means there is no element in the particular set. Universal set means all possible outcomes in the set, and in addition to that there is a concept called as a complement. Okay. So, it is nothing but the set it is usually defined as a 1 minus A. Okay. So, whatever elements are in set A which is not considered, then total set minus, you can say, total items involved in A represents the complement A. So, now there is another question. Suppose we have a two sets, say A and B. Okay. So, how they are related to each other? Just like we have discussed, there are two variables, how they are integrated to each other. In the probability case also same. So, it can be analyzed under one particular variable or one particular event, or it can be analyzed under two particular variable or two particular events. So, now if the question is only one particular event or one variable, and how is the setup? If it is with respect to two variables or more than two variables or more than two events, so then how is the setups? So, now in the case of two variables, say A and B, so then I can represent this universal set like this. Okay. Set this is universal set S. So, within the set I can give a picture here like this. This is set A and this is set B. I will put another examples here, set A and set B. Okay. So, this is A, B, and this is S set. S represents the total number of or total set of set of you can sum of all the individual sets. So, now in the first case set A and set B are totally independent. This is what you usually call it mutually exclusive events. Okay, mutually exclusive events, or it is otherwise called as a disjoint set. That means there is no common element in between. So, the A is a set under inversal set and B is a set under inversal set, but there is no integration between A and B. Just like we have discussed in the multivariate framework, there are several variables in the setup, initial setup. So, we like to know what is the dependent cluster and what is the independent cluster. So, now the speciality of that modeling is that within the independent clusters, we must means we are very much interested whether there is again any integration among the independent variables. If there is so, then the problem may be inconsistent or it may be very complex in nature. So, now there may be situation within the particular setup, all these variables may be independent. If it is independent, then obviously as per the econometric modeling structure, then this is the right track. But in a certain situation or most of the situations, you will find all these independent variables are not independent. There may be some association or relationship between the two. Then in that case, we have to find out the way how to tackle all these, you can say, relationship, or if you cannot avoid, at least you can minimize this particular problem. So, this is how we have to represent the set of mutual exclusive events. So, now in the other case, there are two sets, but there is some integration between A and B. So, now if there is two sets and we like to know the integration, so there are three different structure here. So, now this particular component is the one clusters, and outside of the environment it is called as A complement. Then this is B set, outside of the B it is called as a B complement. So, now within A and B, so we like to know how they are related to each other. That means whether they have some common element or they have not some common element. So, now in that case there is no common element. That means two sets are completely independent to each other. For instance, so I will take an example here. For instance, I will take A equal to 1, you can say 3, 5. This is the set of, you can say, odd numbers. Then I will take another case, B equal to 2, 4 and 6. This is the set of even numbers. So, now this is event A and this is event B, but both are, if I will say S equal to 1, 2, 3, 4, 5 and 6. This is the example of tossing it, or you can say die. So, now there are 6 possible you can say outcomes. So, within the 6 possible outcomes, I have categorically divided into two parts. One is the event which have odd numbers and the event which have even numbers. So, now when I will represent the odd structures, we have 3 elements, that is 1, 3, 5, and when we will go for even elements, then we have again 3 elements, that is 2, 4, 6. But set A and set B are completely independent. So, that is what it is called as a disjoint set. So, this is one typical problem in probability theory. Another typical problem is that both the sets are in the inversal set, but there is some common element. For instance, I will take here the set 1, 2, 3, 4, 5. Okay. So, then another case I will take 2, 4, 6. Then obviously 2 and 4 has a common element. So, now I will take it here. This is 1, this is 3, this is 2, this is 4, this is 5. So, now if B has a even number elements, then 2, 4, 6. So, that means 2, 4 is a common element. So, this 2 and 4 is represented as A intersection B. Okay. So, this the mathematical notation is called as A intersection B. So, now if there is a intersection or this common elements between A and B, so that means if we club together, then it must be the inversal set, provided the two sets are A and B are only two sets in the systems. So, then obviously there is a problem called as A union B. So, A union represents the set of all elements between set A and set B. So, this is how we like to know what is a particular set component set A, what is the particular set component B, then we like to know what is the association between A and B. So, there are two ways they integrate, either they are completely independent or they are dependent. If they are dependent, how they are dependent to each other. Okay. So, this is how the complete structure of, you can say, probability theory. So, now there is a certain other items. For instance, one typical word is called as experiment. So, since the term probability is the quantity measurement, then we have to make so many experiments to get possible outcome, because the situation is totally uncertain. So, we have to make so many experiments to get a particular objective or to fulfill the particular objective. So, now experiment plays a fantastic role in the probability concepts. So, similarly, there is a concept called as a sample space. Sample space consists of, you can say, all observation at a time. So, this is otherwise called as also universal sets. So, now there is a concept called as a event. Event means in a particular case, just like we have discussed set A and set B. Set A may be a particular event, set B may be a particular event. So, now within a particular system, event A, event B may be integrated, may not be integrated. If they are integrated, and how they are integrated to each other. Okay. So, now how do we measure the concept of probability? Generally, probability concept for a particular event, say let us assume that A is an event, A is an event. Okay. So, then probability of A is measured as a number of favorable outcomes divided by number of possible outcomes. That means, total number of possible outcomes in a system and number of a particular event. So, the ratio is called as a probability. So, take a example here. Let us assume that there is a family consist of three members. Okay. So, there is a family consist of 3 members, and the family family cluster is with respect to boys and girls. So, so we like to know what is the probability of having exactly 2 girls in the system and not more than 2 girls in the systems. So, now if there is a question of choosing 3 members in a particular team, then how they are, you can say, integrated, or how the problem can be formulated here. So, now the total space will be like this way. So, now I will call it, instead of boys I will call it B word, and instead of girls I will call it a G words. So, 3 particular situation can be occurred simultaneously. So, there may be a different situation B B B. So, that means there is no girl settles, then B B G, then B G B, then G B B. Okay. So, then B G G, okay, then G B G, then G G B, then G G G. Okay. So, now this is the complete setup. Now, the question is, what is the probability of exactly 2 girls at a time? So, exactly 2 girls means we have to see where only 2 girls are there. So, this is one case, this is another case, this is another case. So, there is no more. So, there are 3 outcome or 3 numbers. So, total sample space on NS equal to 1, 2, 3, 4, 5, 6, 7, 8, and individual sample set NA, which is exactly considered exactly 2 girls, which is nothing but, you can say, 3. So, probability of A is nothing but NA by NS, which is nothing but 3 by 8. So, this is how probability can be calculated. Okay. So, now we like to know various issues of the particular term probability. So, let me explain here what is that issues. So, the basic starting point of probability is like this. For a particular event A, PA equal to NA by, you can say, NS. But you know, like last class discussion, every statistic has its advantage and has its disadvantage. Disadvantage means it has lots of limitation and shortcomings. So, it has also lots of advantage, so that we can apply or you can solve a particular problem. For instance, take a case of covariance. The speciality of covariance is that it traces the association between two variables. However, the limitation part of this particular statistic is that if two variables or if there is any comparative analysis, then the technique covariance cannot be used properly, because it is not at all unitless measurement. So, now in order to solve that particular problem, we have to apply correlation, so that with the help of correlation we can get to know the answers. But again, correlation has an advantage over covariance, but certain situation correlation itself has a lots of limitation. For instance, correlation is unitless measurement and it is advanced than covariance. It is better technique to know the association between the two variables, but in the same time it cannot measure the cause and effect relationship between the two variables. So, for that again we have to look for something else. So, this is how the problem very complex in nature. In every statistic has its advantage and has its disadvantage. So, now in the probability aspects we like to know what is the speciality of particular probability. So, like we have discussed the correlation issue. One of the fantastic feature of correlation is that the value of correlation coefficient lies between -1 to +1. So, similarly, in the case of probability we have also certain advantage, or you can say interesting features. So, one of the interesting feature is that probability of A is always greater than to 0 and less than to 1. So, that means the value of probability is always non-negative. So, it is always non-negative, that means it is always positive. This is the most important properties of probability. Second, sum of pi I equal to 1 to n is exactly equal to 1. That means sum of all probability in a particular setup must be exactly equal to 1. For instance, in a particular setup there are two events A and B. So, obviously, the probability of A occurrence and probability of B occurrence should be exactly equal to 1. First of all, the probability for first event A should be positive and probability for second event B should be positive, and in the final case total probability must be exactly equal to 1. So, these two property has to be fulfilled, otherwise the concept of probability is inconsistent. Okay. So, there are other tricks also, like P probability of A complement, which is nothing but 1 minus P A. Then we have also discussed integrations. So, for you can say P A intersection B is equal to you can say probability of A intersection B divided by you can say N S total sum. In fact, it is number of possible outcomes divided by total number of outcomes. Okay. And for mutual exclusive case, P under A union C is equal to P A plus P C. Okay. Where P A union C usually have P A plus P B minus P A intersection B, A intersection C. Okay. So, this is when there is a they are mutually exclusive or disjoint, then obviously the common element or intersection term will equal to 0. So, simply P A union C equal to P A plus P C. Okay. So, this is how the structure of status of probability, or you can say we can discuss the future of probability. Then there is a concept called as a conditional probability. So, we take a event, there are two events A and B, then then there are two way we have to define the conditional probability. P A given B, which is nothing but P A intersection B divided by P B, provided P B must be positive, means that should not be equal to 0. Okay. Then P obviously P B into P A on given B is equal to P A intersection B. Okay. So, this is case 1, and another situation, probability of P given B given A is equal to probability of A intersection B divided by probability of A. So, that implies probability of A into probability of B given A is equal to probability of A intersection B. Okay. So, now this is equation number 2. So, now if we compare this and this, so then P probability of B into probability of A given B equal to probability of A into probability of B given A. Okay. So, that means probability of B is equal to probability of A into probability of B given A whole divided by probability of A given B. So, this is what the theorem of conditional probability, provided in all the cases the value of probability should be positive and it should be in between 0 to 1. So, it means no situation it should be negative and it should be more than 1. It should be, the limit should be in between 0 to 1, like the term called as a coefficient determinants, which we discussed in the last class, the square of the correlation coefficient. Okay. So, now for independent events, if the two events are independent or disjoint, then probability of A given B is simply equal to probability of A, because it is nothing but probability of A intersection B divided by probability of B, but probability of A intersection B is nothing but probability of A into probability of B, because they are independent. So, probability of B. So, it is simply equal to probability of A. Similarly, probability of B given A is equal to probability of simply B. Similarly, PA into PB divided by PA. So, obviously, the simple answer is PB. Okay. So, now we like to know what is the issue of probability, various aspects of probability, various theorems under probability, and various conditions of probability. So, and within the condition we like to know the conditional probability. This is very interesting component which we discuss in details later stage. So, in fact, there are so many other issues also in probability. This is what we call as a mathematical probability. So, we are not going to discuss details about this issue, because we are very much restricted on econometric modeling. So, our idea or our agenda is to know little bit about the probability issue, so that it is means it will help you a lot for for econometric modeling, particularly to test the reliability issue and to check the significance of a particular variables. Okay. So, now I will discuss here the concept called as a probability distributions. So, we have the issue here, probability distributions. So, before we move to probability distributions, so we must have a thorough knowledge on probability. Then we have to discuss about its distributions. Like we have discussed the univariate modeling. So, that means we like to know what is the central structure, variability structure, and then we have to come for size of the distribution or shape of the distributions. So, in the case of probability also same things. So, we must have the theoretical background of the probability and its structure, conditions, theorems, then we have to see how is it exactly distributions. So, now so far as the probability distribution is concerned, there are two ways it can be discussed, one under discrete series and another under continuous series. Okay. So, let us we discuss first what is probability distribution. Continuous means the variables in intervals, it will be obtained in a interval scale. Okay. So, here it may be finite or infinite, but it is not in interval structures. All right. So, now to analyze the probability distribution, we assume that x is a random variables. So, that means its outcome completely depend completely depends on chance. Okay. So, it is obtained through experiment only. So, this is how it is called as a random variable. X is a random variable. X consists of x1, x2 up to xn, and corresponding probability is equal to p1, p2 up to pn. For instance, what is all about the distributions? Let us take a case. You like to toss a coin. So, obviously, there are two possible outcomes, either head or tail. So, how do you analyze the situation? So, of course, the total outcomes will be 2, head and tail. So, now when we make an experiment, then the situation is totally uncertain. So, now we like to know what are the possible outcomes in that particular structure or systems. So, now first structure is there may not, there may be 0 head, then there may be 0 tails. Now, it is possible when there are 2 outcomes at a time, but when there is a question of only 1, then the game is a very simple one. So, in that case, so either there is a possibility of head or there is a possibility of tail, but now we have to see how much tails are there or how much heads are there. So, now similarly, x is a random variable which represents the number of occurrence, okay. P represents the corresponding probability. So, obviously, the condition is that here. So, in the first case 0 less than pxi less than equal to 1, and second case summation pxi I equal to 1 to n exactly equal to 1. Okay. So, let us take a case here. We like to formulate a probability distributions. Okay. We like to formulate a probability distribution. The condition is that, so the same problem, let us take a case of a family size is 3, okay, and it consists of boys and girls, okay. So, how is the shape of the probability distribution? Boy chance of occurrence is 1 by 2 and girls chance of occurrence is 1 by 2. So, let us assume that the probability of success be equal to 1 by 2 for boys and probability success for girl is p by 1 by 2, just like head and tail. So, the possible chance is 1 by 2 and 1 by 2. So, if it is head occurs, then obviously it is 1 by 2, and if it is tail occurs, it is also 1 by 2. So, now in this particular setup also the situation is almost all same. Here there is 2 alternative only, either boy or girl. So, now how we have to formulate the situation? So, now there are certain case. First case, if all are boys, if all, in all the cases all are boys, okay. So, then there are 3 possible outcomes. So, I mean family size is 3. So, PB into PB into PB. So, obviously, the total outcomes will be 1 by 2 into 1 by 2 into 1 by 2. So, this is 1 by 8. So, now let us another case, all are girls, all are girls, then probability of G into probability of G into probability of G. So, which is equal to again 1 by 2, 1 by 2, 1 by 2 equal to 1 by 8. Okay. So, now similarly, so we like to know what is the case of 2 boys and 3 girls case. In the case of, let us say 2 are boys and 1 are girls, okay. So, then P into BBG plus PBGB plus PGBB, okay. In all the cases here, this is BBG means 1 by 2 into 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 2 into 1 by 2, because in the first case B 1 by 2, then again B 1 by 2, G also 1 by 2. So, in whole total if you solve this particular problem, then you will get 3 by 8. Okay. So, now fourth case, if 2 are girls and 1 boys, this is 2 boys 1 girl, then next case 2 girls and 1 boy. So, the result is also similar. So, that means it will come also 3 by 8. So, now we will formulate a probability distributions. So, now probability distribution, x is a random variable which consists of, you can say, let us say, number of boys in the systems, okay. So, now so x contains, it can be 0, it can be 2, it can be 2, sorry, it can be 1, it can be 2, it can be 3. So, that means the family size consists of 3. So, if there are 3, then there may be possibility 0 number of boys, 1 number of boys, 2 number of boys and 3 number of boys. So, there are 4 possible situations. So, now if there are 3 possible situations, what is the chance of probability? So, now corresponding probability is, for 0 it is already 1 by 8. So, this is 3 by 8, this is 3 by 8, this is 1 by 8. So, now the complete setup is called as a probability distribution, provided it must be satisfy the conditions. So, what is that condition? Now, in every case it is greater than 0, greater than 0, greater than 0, greater than 0, and sum of pi should be exactly equal to 1. So, that means 1 by 8 plus 3 by 8 plus 1 by 8 should be exactly equal to 1. So, it is so 3 by 8 plus 3 by 8. So, it is nothing but 8 by 8, it is exactly equal to 1. Okay. So, now, so there are many ways you can explain, or many examples you can cite to explain this probability issue and also the probability distributions. So, now the interesting aspect of probability distribution is that it can be integrated with the bivariate framework. For instance, we have already we already know what is the concept of univariate and what is the concept of bivariate. Now, if we make a look in probability, how probability can be applied or can be integrated to univariate structure and can be integrated to bivariate structure. The way we have discussed till now, it is more or less univariate structure of probability distributions. So, that means every time we are discussing a single variable or single event, then we are finding out the various possible outcomes or various possible scenarios. So, now if there are 2 different variables, for instance, take 2 random variables, say x and y, and they have corresponding probability, then how x and y are integrated to each others, just like the correlation structure and covariance structure. We can also justify here how it is the problem setup. Okay. So, now take a case of 2 variables, x is one variables and y is another variables. X contains x1 up x2 up to xn, corresponding probability is p1, p2 up to pn. So, in the case of y, the corresponding situation is y1, y2 up to yn, corresponding probability is p1, p2 and pn. Alright. So, now you make a look here. When we look for simple structure, so we have series x1 up to xn, then another series y1, y2 up to yn. Okay. So, what is our agenda here? We like to know what is x bar, what is variance of x, what is standard deviations of x, what is the skewness of x, and so on. Okay. Similarly, this is y bar, variance of y, this is sigma upon y and skewness of y. This is the entirely or complete structure of univariate setup. So, now when we will move to bivariate structure, then we like to know how they are integrated to each other, and for that we either apply covariance upon x y, or we can apply correlation upon x y, or you can also have it through b x y or b y x. Okay. So, this particular structure is not at all attached with, you can say, the concept of probability. So, now the same setup can be integrated or can be interpreted through probability issue, because lots of instances, or you can say many occasions, your variables are random in nature. That means the outcome of a particular variable entirely depend upon chance. In that case, probability has to be applied. Okay. So, now we like to know if it is applied in that particular case, then how is the setup. So, we like to know how the probability structure can be applied to this univariate setup to bivariate setup. So, now when the outcomes are like this, only x equal to x 1, x 2, x n, no probability, then the situation is completely certain. So, that means there is no question of uncertainty. So, that means the chance of occurrence is not at all an issue. So, now whatever you are expecting, the same results with you. So, this is what the certain issue, but when there is a question of uncertainty, then probability has to be applied. So, that means, so now the issue is we have to multiply probability with the original variable. So, corresponding term is p 1 x 1, p 2 x 2, then p n x n. So, like here samples, sample mean. So, we will also call x bar, which is nothing but we will call expected value of x, because since it is quantitative measurement of uncertainty, then obviously we are expecting something. Okay. So, now expectation has to be applied. So, now you are expecting something. So, what is that expectation? Is it 100% or is it less than that? If it is 100%, then obviously the probability, chance of probability is exactly 1. So, if it is, you can say no, then its probability almost all it is impossible, it is 0. Okay. So, now x bar is nothing but Ex. So, which is nothing but summation p I x I equal to 1 to n divided by summation p I. You remember one thing, in the first lecture under univariate modeling, we have discussed the univariate statistic, particularly with respect to mean, median, modes, and under mean we have different setup like arithmetic mean, harmonic mean, and weighted average mean. So, now that weighted average is nothing but the probability issue. This probability is just like a weight issue. So, it is assigned weight to a particular every items. So, now with this setup, if you understand the concept of weighted average mean, then obviously there is no confusion about this expectation in the probability theory. So, now in the case of weighted arithmetic mean, so we applied summation Wi. So, now here summation Pi. Okay. So, now this is x or expected value of x or mean of x under the probability distribution. Similarly, so here we will get Py. So, this is actually y structure and this is also p structure. So, we will get Py. So, Py is nothing but P1 y1, P2 y2 up to Pn yn. So, corresponding to y and its probability. So, we can get expected value of y. Expected value of y is nothing but summation Pi yi I equal to 1 to n, and remember this is nothing but simply summation Pi xi, because sum of Pi is exactly equal to 1. So, obviously it is also summation Pi. So, which is nothing but summation Pi yi. Alright. So, now this complete setup is called as a you can say mean of A and mean of B. Alright. So, now we like to know the movement from univariate structure to bivariate structures with simple setup where the situations are very certain in nature. In another case, the situation are completely uncertain in nature, where the structure is not at all simple. The structure is assigned or designed with weight factors or probability factors, chance of occurrence of that particular items. Okay. So, now moving to that particular issue. So, now for x and y, so x1 y1 sorry x1 x2 up to xn, p1 p2 pn. So, then y1 y2 up to yn, p1 p2 and pn. So, Ex is equal to summation pi xi I equal to 1 to n. So, this is nothing but x bar. Similarly, E upon y is equal to summation pi yi, which is nothing but you can say y bars. Okay. So, this is Ex. So, now we can get it also Vx. Vx represents variance of x. So, now variance of x is nothing but Ex squares minus Ex whole squares. Okay. Similarly, variance of y is equal to Ey squares minus E upon y whole squares. Okay. So, you have Ex and Vx. So, that means it is the univariate structure with respect to central issue, and this is with respect to dispersion issue. So, now if we like to know standard deviation, then it is nothing but square root of Ex square minus Ex whole squares. Okay. So, similarly, sigma y is nothing but variance of y factors. All right. So, now so you like to know Ex Bx, Ey By. So, now we like to correlate x upon y. So, for that we need to have covariance of xy. So, covariance of xy is nothing but E upon xy minus Ex into Ey. Okay. So, now what is Exy? Exy is simply represented as a summation pi pj xi yj I equal to 1 to n. Okay. So, with this issue, so this is the covariance issue, this is variance issue, and we need to have a final outcomes, that is correlation between x and y. So, correlation of xy is nothing but covariance of xy divided by sigma x into sigma y. So, that means it is nothing but Exy minus Ex into Ey divided by you can say sigma x into sigma y. So, like correlation, so this also satisfy, this is usually denoted as rho xy is equal to 1. Okay. So, now so we get to know what is the issue of probability, its various structure, various setup, and how it is useful for real world business problem, and how it is helpful when the situations are not certain at all. That means it is the question of uncertainty. So, that means probability has to be applied when the situations are very much uncertain in nature. So, that is why it plays a very fantastic role in econometric modeling. So, like you know, original samples we discuss about univariate statistic and bivariate statistic, that is with respect to covariance and correlations. So, we have to apply probability with the particular samples, then we can also get to know the what is the univariate setup and bivariate setup. So, this is you can say very much helpful, or you can say it is very useful for further econometric modeling. So, now in addition to probability, the estimation and hypothesis testing plays a fantastic role, which we will discuss in the next class in details. So, with this we can conclude this class today. Thank you very much. Have a nice day.